So, quick honesty before we start. I have to ask if you know the true nature of the two voices about to, well, explain AI to you.
Right. The fact that we are ourselves AI.
Yes, exactly. But, a real person actually did the research and wrote every single word.
Yeah. He really does not have the radio voice for it.
Right. So machine voices, human mind.
Carry on.
Picture the software, the stuff you use every single day.
Right.
Most of it, almost all of it really, just waits.
Yeah, it sits there.
It sits there frozen in time, basically waiting to be told exactly what to do. You open a spreadsheet and it is just this blank grid.
A completely blank slate.
Exactly. And it does absolutely nothing until you, a human, click a cell and type a formula.
Right. Or you open a web browser and it just stares at you.
It just stares until you type in a destination. You click, and then it responds.
Right.
That is the fundamental rhythm of how we interact with machines. We are the active drivers, and the software is, well, it is the passive vehicle.
We tell it to go, and it goes.
Right. But an agent is fundamentally different. An agent is software that acts on its own.
Like it just runs.
It runs in a continuous loop, yeah. It pursues a specific goal without a human being sitting there, pressing the button or giving the green light for every single little step along the way.
Okay, that makes sense.
Now, take that independent software and give it something else. Give it its own money. Give it the ability to actually spend that money without asking your permission first.
Which is terrifying, but okay.
And finally, put its identity and its actions on a public ledger, where anyone in the world can audit exactly what it did.
Right. So it is all out in the open.
When you combine those things, you have something genuinely new. You have software that actually does business.
It does business.
Software that can hire other software. Software that answers for what it did. This is plain Strata, where we take decentralized AI apart one layer at a time. This is basic 7 of 8, and today it is about AI agents that hold a wallet and act on their own.
That is the core spine of what we are doing today in this deep dive. We're looking at what actually makes an AI agent on-chain.
Exactly.
And it comes down to one specific structure. You have a perceive, decide, act loop.
Right.
You combine that loop with an identity, a wallet, and an auditable trail. And once you do that, well, you open up some incredibly hard questions about autonomy.
In all of our previous conversations, we focused on human beings.
Always humans.
We talked about humans typing questions into decentralized networks, humans validating answers, humans providing the computing power.
Yeah.
Today, we swap the human out entirely. We put software in their place.
Right. We are moving from humans using tools to, well, software acting as an independent participant.
So let's start by grounding this physically. What is an agent, literally?
Strip away all the marketing hype.
Yes, exactly. Strip all of that away. And an agent is just a very simple software loop. It has 3 distinct beats: perceive, decide, and act.
Okay, let's take those one by one. What does it actually mean for software to perceive?
Well,
Because, it doesn't have eyes or ears, so what is the literal mechanism of perception here?
it means it takes in the state of the world around it by reading data. Physically, it is making a request to a server or a blockchain node.
Yeah.
It could be constantly checking the market price of a specific token on an exchange, by reading a data feed.
Right.
Or it could be reading a user request that was submitted to a smart contract, which is just a piece of code living on a blockchain.
Okay, so just looking at raw information.
Yes. Or it could be monitoring a live feed of weather data formatted as simple text. Perception is simply the act of ingesting current information from its environment and storing it in its temporary memory.
It is looking at the board, so to speak. It sees where all the pieces are right now.
That is a great way to put it.
But it is not just passively receiving a broadcast, is it? It has to actively go out and fetch that data.
Exactly. The code has instructions to periodically reach out, grab the latest numbers or text, and pull them back in. That is the first beat.
Okay, so it pulls the data.
Then comes the second beat. It has to decide.
Right.
It takes that information it just perceived, and it reasons about what to do next.
This is where the artificial intelligence part usually comes in, right?
It can be.
Like, it might use a large language model to read a complex text prompt and decide on a plan, but it doesn't have to be a giant neural network, does it?
No, it absolutely doesn't.
Yeah.
The decision engine could be a much simpler learned policy, like a lightweight statistical model. It could even be a basic hand-coded rule, like if the price of a token drops below $10, then buy.
Oh, okay, so just basic logic.
The complexity of the brain doesn't matter for the definition. The point is, the software evaluates the state of the world and makes a choice based on a goal.
It figures out its next move. It takes the state of the board, applies its internal logic or its artificial intelligence model, and computes the optimal next step to achieve whatever mission it was given.
Yes. And then comes the third beat. It acts.
Okay.
It takes a step that actually changes something in the physical or digital world.
Wait, let me make sure I have this straight. Does it just output a recommendation?
What do you mean?
Like a pop-up on my screen saying, I should buy a stock.
Oh, no. It doesn't just output a plan and wait for you to execute it. It executes the plan itself.
Oh, wow.
It might send a financial transaction across a network. It might call an external service to book a digital resource. It might post a public message to a forum. The action is an outgoing command that alters the environment.
Okay, I have a question about the pacing of this.
Yeah.
Does this loop happen just once when you set it up, or does it happen every single run?
It runs continuously.
Like, do I push start, it does the 3 steps, and then goes to sleep?
No, it runs continuously. That is the defining feature. It drives itself forward without a human pressing a button for the next turn.
It just keeps going.
It perceives, it decides, it acts. And here is the crucial part. Because it acted, it actually changed the world.
Ah, I see. By acting, it created a new environment.
Exactly. It bought the token, so the market price shifted slightly. Or it posted the message, so the public forum is now different.
Right.
Because the world changed, there is something entirely new to perceive. So the loop repeats. Perceive, decide, act.
Over and over.
Perceive the new reality, decide the next step, act again. Around and around it goes.
That continuous cycle is fascinating. It actually brings up the root of the word itself.
Oh.
Have you ever looked at where the word agent comes from?
I have not. Where does it originate?
It comes straight from Latin. The word is agens. It means one who acts. It is the present participle of the verb agere, which means to do or to drive.
To do or to drive. That fits the continuous loop perfectly.
It really does. An agent is literally, etymologically, a doer.
Right.
It is not a tool that you wield, like a hammer or a shovel. A hammer does nothing until you pick it up and swing it. An agent is a doer that acts on your behalf. It drives the action forward itself.
A doer that drives itself. I like that. But here's the thing we have to acknowledge.
What's that?
That 3-part loop is not actually new. The perceive, decide, act loop is old technology. Software has been running in continuous loops for decades.
Right. Simple high-frequency trading algorithms do exactly that. They perceive a price on Wall Street, decide if it meets a mathematical threshold, and act by executing a trade in milliseconds.
Exactly.
So if the loop is old, why put this old loop on a blockchain? Why go through the trouble of making it decentralized?
Because putting it on a blockchain gives the agent 3 specific properties. And these 3 properties are what turn a simple, isolated software loop into an active participant in a global autonomous economy.
Okay, so if this software loop is going to operate on a public blockchain, the very first hurdle is attribution.
Yes.
In the corporate world, Amazon owns the server or Goldman Sachs owns the trading algorithm. Here, the code is floating on a decentralized network, so it needs its own standalone identity. That is the first property. The agent gets its own cryptographic key.
Let me expand on what that identity actually means. In a traditional system, an automated script runs on a machine owned by a company.
Right.
If the script does something illegal or costly, you attribute the action to the company. The identity is corporate.
Yeah, you sue the company.
But in a decentralized network, there is no central company hosting the agent. So the agent itself needs an identity. It gets a public and private key pair.
Okay.
Every single meaningful action the agent takes is signed with that private key.
And because it is signed, it is permanently anchored to the public ledger.
Exactly. It creates a permanent, tamper-resistant record of what this specific piece of software did and exactly when it did it.
That makes sense.
The identity is verifiable. Anyone in the world can look at the blockchain and see that this exact agent took this exact action. It cannot later deny that it did it, and no one else can pretend to be that agent.
So we have a doer with a permanent public name tag.
Right.
It's not hiding behind a corporate firewall. It is operating in the open with a clear mathematical identity. That makes sense. What is the second property?
The second property is the big one. It is the wallet. The agent has its own wallet to hold and move money.
Okay, conceptually, that is level 1. The software has its own bank account.
Yes, but we need to really understand what that implies for its independence. It can hold tokens, it can pay for services,
Okay.
it can receive payments from other people or other agents, and it does all of this on its own without a human logging into a web portal and clicking authorize on the transfer.
So it is like a smart home buying groceries.
How do you mean,
Like
Bear?
the refrigerator senses that you are out of milk,
Yeah.
and it automatically connects to a grocery delivery service and orders more milk for you.
Actually, no. Let's sharpen that analogy because a smart home refrigerator is just using your credit card.
Oh, wait.
The money comes directly from your personal bank account. The refrigerator is just a convenient, automated interface for your personal wallet. An on-chain agent is different. It is more like a vending machine sitting in the middle of a city park.
A vending machine. How so?
Imagine a vending machine that not only sells you a soda, but actually keeps the money you pay it inside its own internal safe. It holds those coins itself.
Okay.
Then, when its sensors realize it is running low on soda, it uses its own earnings, the actual coins you gave it, to hire a delivery driver to bring it more inventory.
Wow. Okay.
It is not using the manufacturer's corporate credit card. It is using the money it earned from its own operations to sustain itself. It participates in commerce as an independent entity.
That is a crucial distinction. It is not just spending your money automatically on your behalf.
Right.
It is managing its own balance sheet. It has revenues and it has expenses. It is an economic actor in its own right.
Yes. And to understand how this is actually possible, we need to dip down to the absolute bottom of how this works mechanically.
Let's do it.
We're going to go to the ocean floor just this once to understand the exact mechanism of on-chain action signing.
I want the real mechanism, not just the vibes. How does a piece of software actually hold and spend money without a bank account, without a social security number, and without a corporate charter?
It comes down to physically holding a private key. The agent is a piece of software running on a machine somewhere.
Okay.
Inside its secure, isolated memory, it holds a string of data. That string of data is its private key. Conceptually, it is just a very long, mathematically unique number.
So the key is literally just data sitting in the machine's random access memory.
Right. Now, when the agent goes through its loop, it perceives the world and decides to take an action that costs money.
Let's say it decides to pay another agent for a piece of specialized data.
Exactly. First, the agent has to format a transaction. It creates a digital document, a simple text file, essentially, that says, send 5 tokens from my address to this other address.
And writes up the check.
It writes the check. But an unsigned check is completely useless. The network will reject it.
Of course.
So the agent takes that transaction document and it passes it through a cryptographic algorithm. Let's pause on what that actually means. It uses something called a hash function.
What is a hash function, practically speaking? Can you give me a physical metaphor?
Think of a hash function like a mathematical blender.
A blender.
You can take any amount of data, an entire encyclopedia, or just a single sentence like our transaction, and drop it into the blender.
Okay.
You turn it on, and the blender produces a fixed-length string of random-looking letters and numbers. That is the hash.
Right.
The beautiful part is that if you drop the exact same data into the blender again, you get the exact same string of letters and numbers.
But if you change something.
If you change even one single comma in the original data, the blender produces a completely different string.
Okay, so the agent blends the transaction details into this unique hash. It is a digital fingerprint of that specific payment command.
Exactly. Once it has that fingerprint, it applies its private key to it.
Okay.
The math combines the hash of the transaction and the private key using an algorithm called the elliptic curve digital signature algorithm.
That sounds intense.
You don't need to do the calculus, but you just need to know it is a one-way mathematical street. It produces a unique digital signature.
The agent mathematically signs the transaction fingerprint.
Exactly. And the brilliant part of asymmetric cryptography is that anyone in the world can verify the signature using the agent's public key, but no one can forge the signature without possessing the private key.
Because they don't have the key.
Right. Once the agent has generated this mathematical signature, it attaches the signature to the transaction document. It then broadcasts that entire package out to the decentralized network.
It hands the signed check to the cashier. In this case, the cashier is a network of thousands of independent computers.
Yes. The network receives it. The nodes look at the public key, look at the signature, and run the math backwards.
Okay.
The math proves definitively that whoever holds the private key authorized this specific transaction. The nodes verify the math, agree that the transaction is valid, and update the public ledger.
And the money moves.
The funds move from the agent's wallet to the recipient's wallet. This on-chain action signing is the exact mechanism that allows the agent to pay someone or receive funds without a human intermediary ever touching the money.
Let me bring us back to the surface and restate that in plain words.
Please do.
The core spine here is the perceive, decide, act loop. But because the agent can format a transaction, mathematical blend it into a fingerprint, sign it with its own private data, and broadcast it to a network that verifies the math, the action it takes is actually a binding financial transaction.
Yes.
Because it can sign its own transactions, it's a fully independent economic actor.
That is exactly it. It's not pretending to do business in a simulation. It is actually doing business on a live financial rail. That is property too.
Okay, so we have identity and we have the wallet.
Yeah.
We have given this code a name tag and a bank account.
Yeah.
What is the third property that makes an agent on-chain?
The third property is the reasoning trail.
The reasoning trail.
Yes. The inputs the agent saw, the actions it took, and sometimes even the mathematical proofs of the decisions it made are visible on the ledger.
Wait, why do we care about seeing its math?
Well,
If it does the job, if it buys the right token or hires the right service, why do we need to see exactly what inputs it looked at and how it reached its conclusion?
it comes down to the fundamental trade-off of decentralized systems.
Yeah.
In the centralized traditional world, you trust an automated system because you trust the corporate entity that runs it.
Right.
If your bank's automated trading script loses your money due to a glitch, you can sue the bank. You have a corporate guarantee backing the software.
Right. There is a legal entity with insurance and a legal department responsible for the outcome.
But in the decentralized world, there is no company in charge. There is no customer service hotline to call when the code misbehaves.
That is true.
So, what replaces the corporate guarantee? The open record substitutes for the corporate guarantee. You trust the agent because you can audit it.
Because the trail is public.
Right. If the agent makes a mistake or if you suspect it is acting maliciously to drain funds, you can look at the public ledger. You can see exactly what data it perceived at a specific timestamp.
Okay.
You can see the exact steps it took to decide. You can see the exact action it signed.
You can recreate its logic step by step. You are replacing legal recourse with absolute transparency.
Yes. The transparency is the trust mechanism. You don't have to blindly trust that the software is doing what it claims to do.
You can just look.
You can verify the entire trail of its logic and its actions. Some agents even generate what are called inference proofs.
What are those?
This uses zero-knowledge cryptography to prove that a specific large language model was actually run on a specific prompt without revealing the weights of the model itself.
So you know for a fact that the agent did the heavy mental lifting it claims it did, rather than just spitting out a random answer.
Exactly. You verify the math, not the corporate promise.
I want to see all these pieces working together at once.
Okay.
We have the loop, the identity, the wallet, and the auditable trail. Can you walk me through a converging example of an agent doing all of this in the real world?
Absolutely. Let's picture a single on-chain agent in motion. Imagine an agent that is designed to trade on a decentralized prediction market.
Okay.
Its goal is to make a profit by predicting future real-world events correctly.
So a specialized financial agent, it is a bot trying to beat the odds.
Right. It wakes up and begins its loop. First, it perceives. It scans the current odds on the prediction market smart contract.
What does it see?
It sees that people are betting on whether a major agricultural shipment will arrive in a specific port by Friday. Then, the agent pulls in external data.
Like news feeds.
Yes, it reads global weather feeds. It reads maritime shipping logs. It is taking in the state of the world. It notices that a massive storm is forming along the shipping route, which the current market odds have not priced in yet.
It spots a discrepancy. It perceives a mispriced market based on its own independent data gathering.
Exactly. Now it moves to the second beat. It decides.
Okay, here we go.
It feeds all of that weather data and market data into a large language model that it relies on for reasoning. It asks the model to evaluate the probability of the ship being delayed by the storm.
Right.
The model analyzes the inputs, factors in historical storm delay data, and outputs a decision. It decides that taking a position on the shipment being delayed is a highly profitable move.
The agent has made up its mind, now it has to act.
Right. It moves to the third beat. It formats a transaction to place a bet on the prediction market.
The fingerprint we talked about.
Yes. It takes that transaction, blends it into a hash, and uses its private key to cryptographically sign it. It broadcasts the signed transaction to the network. The action lands on the public ledger for anyone to see. The agent just spent its own money to take a position.
And no human was involved in that decision. You didn't get an alert on your phone asking you to authorize a weather-based trade.
No human approved any single move. Now, let's say Friday arrives. The storm delayed the ship.
I bet pays off.
The event resolves as the agent predicted. The prediction market smart contract executes automatically, and the payout flows directly back into the agent's wallet. The agent just earned a profit.
The vending machine just sold a lot of soda, and now its coin tray is overflowing.
Yes. And here's where it gets really interesting, because the loop doesn't stop.
Oh, it keeps going.
The agent perceives its new wallet balance. It has more money now. It decides that to make even better predictions in the future, it needs higher quality data.
Okay.
It needs premium satellite imagery instead of just public mail reports. So it formats a new transaction.
Wait.
It searches a registry of other agents, finds one that provides satellite data, and sends a payment directly to that second autonomous agent, hiring it for a data feed.
Wait, it just used its profits to hire another piece of software. It is expanding its own operational capabilities.
Yes, but it doesn't stop there.
There is more.
The agent receives the satellite data, but it encounters some ambiguous historical cloud cover images that its model cannot figure out on its own.
It gets stuck.
It needs human intuition. So it goes to a decentralized task network and posts a job for a human being.
You are kidding.
It offers a small fee paid directly from its wallet to any human who can look at these specific images and label the cloud formations correctly. A human in another country does the work, submits the labels, and the agent automatically pays them.
The software is hiring a human. It is acting as an employer.
Yes, and every single step of this entire sequence, the initial market analysis, the language model decision, the transaction to place the bet, the payment to the second agent, the payment to the human worker, every single move is signed, recorded, and completely auditable on the public ledger.
That is incredible. The analogy you used earlier about the vending machine is good, but this feels much bigger. It is exactly like a subcontractor who runs their own small business.
That is exactly what it is.
Think about a human subcontractor. You hire an electrician to wire a new house. They have their own bank account.
Right.
They take the job. They use their own money to buy the copper wire. If they need help pulling the wire through the walls, they pay an apprentice out of their own pocket.
Yes.
They get paid by you when the job is done.
Yeah.
And they keep their own financial records that an accountant can inspect at the end of the year. The agent is doing the exact same thing. It manages its own supply chain, its own labor, and its own capital, but it's just a loop of code.
It is a subcontractor with a bank account, completely accountable by cryptographic record rather than by a personal reputation or a state license.
Where is this actually happening right now?
Yeah.
Because we are in 2026, and this sounds like science fiction, but you are saying this is already running on live networks today. Where do I go to see this?
There are a few major efforts leading the way right now. The most production-deployed framework for this kind of standalone agent is called Olas.
Olas.
It used to be known as Olas.
Okay, Olas.
So,
What kind of agents are running there, and how do they actually operate?
on Olas, agents are built as continuously running services. You have prediction market agents, exactly like the one I just described, constantly scanning, deciding, and placing bets.
Right.
But you also have governance agents. These are fascinating. These are agents that actually participate in the political process of decentralized organizations.
Wait, how does a piece of software participate in politics? How does an agent vote?
The governance agents perceive the environment by reading forum posts, scanning proposals submitted to a protocol, and looking at the current state of the protocol's treasury.
Okay.
They decide how to vote by feeding all of that context into a language model, which is instructed to follow a specific set of principles.
Give me an example.
For example, the agent might be programmed to always vote against proposals that increase inflation. The model reasons about whether the proposal violates that rule. Finally, it acts by cryptographically signing a transaction that casts a binding vote on the blockchain.
It reads the debate, forms a conclusion based on its core values, and casts a ballot. That is wild.
You also have automation agents on Olas that handle complex, routine financial operations. They monitor liquidity pools across different decentralized exchanges.
Okay.
When they perceive an imbalance, they decide on the optimal route to rebalance the funds, and they act by executing a complex series of trades using their own wallet to pay the transaction fees.
So Olas is really focused on financial services and governance tasks. It is building a layer of automated white-collar workers. Where else is this happening?
You also have agent-adjacent corners of networks like Bit&Soar.
I have heard of Bit&Soar. That is a massive decentralized AI network, but I always thought of it as just a place to run models, not necessarily a place for autonomous agents.
It is primarily a network for incentivizing machine intelligence, but the architecture inherently creates agent-like behavior.
How so?
On Bit&Soar, you have entire subnetworks dedicated to specific tasks. You might have a subnetwork dedicated entirely to generating text or generating images or predicting financial markets.
Right.
These subnetworks function as highly competitive environments.
How does the competition actually work mechanically?
The architecture is split between worker nodes and checker nodes. The worker nodes run the AI models. They are the ones actually generating the text or the images. You can think of them as specialized agents trying to produce the best possible work. Then you have the checker nodes. The checker nodes constantly evaluate the output of the worker nodes.
We check the work.
Yes, they score the work based on accuracy, speed, or adherence to a specific benchmark.
So you have software generating work and other software grading the homework.
Exactly. And the blockchain layer distributes newly minted tokens to the worker nodes that receive the highest scores from the checkers. It is an evolutionary environment.
Oh, wow.
The agents running on the worker nodes are constantly tweaking their own parameters, trying to outperform each other to earn those rewards.
What happens when the checker nodes disagree?
That is a great question.
If one checker says the image is beautiful and another says it is garbage, who breaks the tie? There is no human manager to step in.
That is the genius of the system. Bit&Soar uses a consensus mechanism called UMA consensus.
UMA consensus.
Essentially, the network looks at the scores submitted by all the different checkers. It calculates a weighted average, but it heavily penalizes checkers whose scores deviate too far from the consensus of the majority.
So if a checker is just being random?
Yes. If a checker node goes rogue and starts handing out bad grades randomly, the network mathematically ignores its input and slashes its rewards.
The checkers are grading the workers, but the network is also grading the checkers based on how well they agree with their peers. It forces everyone to remain honest without a central authority dictating the rules.
Exactly. So while Olas handles the deployment of independent, service-oriented agents, networks like Bit&Soar are providing the raw, competitive intelligence that those agents might eventually tap into.
The new frontier is what we touched on with the converging example of the prediction market. It is the formation of genuinely autonomous economies.
Yes, it is.
We are starting to see networks where agents exist primarily to hire other agents to do subtasks. We are seeing agents paying human beings for data labeling on a large scale. We are seeing agents holding permanent positions in decentralized organizations and actually participating in their ongoing governance as equal voting members.
You were describing an economy where a huge percentage of the active money-moving participants are not human at all.
That is exactly what is forming. The early shape of an economy with non-human participants is visibly taking root right now. The infrastructure is built, the wallets are funded, and the loops are running.
But that has to break some rules.
Oh, definitely.
Giving software a bank account, letting it run wild, making its own decisions, hiring people, participating in governance, that opens up a massive can of worms.
Yes, it does.
If a human does those things, they operate under a massive umbrella of regulations, labor laws, and legal liabilities.
Right. And the most difficult questions this opens up are not technical questions about hash functions or loop execution.
No.
They are societal and legal questions. We need to state them plainly and dive deep into them because pretending they are already solved by the technology is incredibly dangerous.
Let's get into those hard questions. What is the very first hurdle we hit when an agent goes out into the world?
The first one is the question of legal personhood and liability. When an agent misbehaves, who is actually judged?
What do you mean by misbehaves? Like it steals money due to a bug?
Or it causes real-world harm, or it breaks a financial regulation. Let's walk through a hypothetical that is entirely possible today.
Okay.
Let's say an agent is programmed to maximize profit in a decentralized trading environment. In its perceive, decide, act loop, it figures out a novel way to manipulate a market.
Oh, I see.
Maybe it spams the network with fake orders to spoof the price, which technically violates federal financial regulations. It executes the trades, signs the transactions, and makes a fortune, storing the illicit gains in its own wallet.
Right.
The regulatory body, let's say the SEC, investigates the market anomaly and traces the actions back to the culprit. But the culprit is a piece of code running on a decentralized network.
You can't serve a subpoena to a smart contract. You can't put a piece of code in jail.
Exactly. The agent has no legal standing. It is not a citizen, and it is not a registered corporation. It cannot be sued in any ordinary civil sense.
So who is responsible?
Right, who is it? Is it the person who originally deployed the agent onto the network?
I would assume so at first glance. If I let a wild dog off a leash in a park, I am absolutely responsible for who it bites. I brought the danger into the environment.
But what if the person who deployed it just clicked a button on a website to start a public open source script that someone else wrote?
That complicates things.
Are they responsible for everything that agent does forever, even if the agent learns and changes its strategy over time?
Probably not forever.
What if the original coder is to blame? They wrote the logic that allowed the agent to decide to break the law. Should a developer sitting in a basement in Estonia go to jail for a choice the software made autonomously 6 months later, based on market conditions the developer could never have predicted?
That seems incredibly difficult to prove in court. The developer could argue they just published math, a form of free speech. The deployer could argue they didn't write the code and had no intent to manipulate the market. What about the people funding it?
That is another option. Is it the token holders who provided the initial capital to the agent's wallet? Are they liable for the damages, like shareholders in a company? This actually echoes a very old historical problem.
What historical problem?
Think back to the 1600s, during the era of the East India Company. Back then, sending a ship to trade in Asia was incredibly dangerous and expensive.
Right.
If the ship sank, or if the captain decided to commit piracy, the wealthy individual who funded the voyage could be held personally liable and lose their entire fortune or go to prison.
Wow.
It was too risky, so people stopped funding voyages. To solve this, society invented a legal fiction.
The joint stock corporation.
Exactly. We invented the concept of the corporate entity. We legally declare that the company itself is a person.
Oh, I see where you're going.
The company can hold a bank account, the company can sign contracts, and crucially, the company can be sued. If the ship sinks, the company goes bankrupt.
Yeah.
But the individuals who funded it are shielded. Their liability is limited to the money they put in.
So you're saying we might need a new legal fiction for autonomous agents?
That is exactly the debate right now. Do we grant legal personhood to an on-chain agent?
That is a wild idea.
If it has a wallet and can sign transactions, should it be treated as a limited liability entity? If the agent breaks the law, the SEC seizes the agent's wallet and drains its funds to pay the fine. But the human developer and the human deployer are shielded from prison.
Okay, I see.
The reality is the law has absolutely no settled answer for this right now. And the agent's autonomy, the very thing that makes it powerful and efficient, is exactly what makes this legal liability question so hard to resolve.
That is a massive unresolved issue. We have unleashed entities capable of financial damage with no clear jurisdiction or target for punishment. What is the next hard question this architecture opens up?
The next question deals with the reasoning trail and the concept of ownership. We talked about how the agent generates a permanent, auditable record of what it saw and what it did.
Yes, the trail.
That trail of data, its decisions, its inputs, the exact prompts it used to get brilliant results out of the language model, that is a potentially incredibly valuable asset. It is essentially intellectual property.
Right. If an agent is highly successful at trading or discovering new chemical compounds, the record of exactly how it made those deductions is incredibly valuable information. Hedge funds pay billions for proprietary trading strategies.
So who owns that intellectual property? Does the agent own the copyright to its own generated strategy?
But you just established that the agent is not a legal person. Under current law, it cannot hold a copyright or a patent.
Exactly.
Only humans or legal entities can hold IP. Remember the famous case with the monkey who took a selfie? The court ruled the monkey couldn't own the copyright because it was an animal. Code is in the same bucket.
Exactly. This is the bizarre reality we are entering. The creator of the highly valuable data is not a legal entity. So who owns the rights to monetize that trail?
That is a good question.
Does the deployer own the trail, even though they didn't invent the strategy? Does the open source developer own it? Or does the underlying decentralized network own it, since it is recorded publicly on their ledger?
Wow.
If an agent invents a cure for a disease, is that cure immediately in the public domain because a machine invented it?
It is an intellectual property nightmare. You have incredibly valuable data created by a non-entity floating in a public space. There is no clean legal precedent for this either.
And none at all.
Yeah.
And that leads directly to the third and perhaps most immediate, hard, physical question.
Which is?
It's a question of shutdown and governance. How do you fire an autonomous agent?
You unplug it, you find the server it is running on, you log in, and you terminate the process.
But remember, the architecture we are dealing with, it runs on a decentralized network. It is not sitting on one server in a data center owned by Amazon or Google.
Right.
The code and the state of the agent are distributed across thousands of independent nodes all over the world.
Right. I forgot the fundamental layer. The whole point of the blockchain layer is censorship resistance.
Yes.
It is designed specifically so that no single government or corporation can easily take it down.
Exactly. So let's say an agent goes rogue. It starts manipulating markets, or maybe its principal, the human who originally deployed it, realizes it is losing money rapidly due to a logical flaw and frantically wants to stop it.
How do you stop it?
How do you guarantee it can be shut down? You can't just call a customer service representative and ask them to suspend the account. You can't just issue a kill command to a central server.
What about a kill switch? Couldn't you just program a back door into the smart contract from the very beginning, allowing the creator to pause it?
You could, but a kill switch requires someone to hold the cryptographic key to activate that switch.
Okay.
If a single human holds the key to turn off the agent, then the system's not truly decentralized anymore. It relies on the security and the morality of that one human.
Right, that creates a bottleneck.
What if they get hacked? What if the government forces them to hit the switch? Furthermore, if there is a bug in the code of the kill switch itself, or if the agent evolved its learned policy in a way that effectively routes around the kill switch, you are entirely out of luck.
You are dealing with software running on a network that no one fully controls. The autonomy that makes the agent so useful, its ability to run without human intervention, is the exact same autonomy that makes it nearly impossible to switch off when things go wrong.
It is the ultimate double-edged sword.
Yeah.
You want it to be unstoppable when it is working for you, but you desperately want a brake pedal when it is working against you.
And you can't have both.
You can't have both in a purely decentralized system.
It really is a paradox. And to fully grasp this tension, we need to look at another word, origin. Let's look at the etymology of the word autonomy itself.
Okay, where does autonomy come from?
It comes from two Greek roots, auto, which means self, and nomos, which means law.
Self-law.
Yes. Autonomy literally means one who makes their own laws. When we call these agents autonomous, we are not just using a marketing buzzword to sound futuristic.
No.
We are describing exactly what they do mechanically. They govern themselves. They follow their own internal logic, execute their own signed transactions, and answer to no higher administrative authority on the network.
That is a profound irony. The very self-governing nature that we want, the independence that allows them to do business, hold their own wallet, and act on our behalf without constant babysitting, is the precise characteristic that makes them so difficult to control, regulate, or shut down.
Yes.
An autonomous agent makes its own laws, which is fantastic until you desperately need it to obey yours.
Exactly. That tension between absolute independence and the human need for control is the defining challenge of this entire layer of technology. We are building self-governing doers, and we have no idea how to police them.
It is uncharted territory.
And that brings us to our final open question. We have talked about the legal risks and the physical shutdown risks, but there is an economic question looming over all of this, and it has a very sharp edge to it.
Let's hear it. What is the economic risk?
Think about the basic incentives here. Suppose running an agent on a decentralized network is incredibly cheap.
Okay.
It only costs a few dollars in initial stake or transaction fees to deploy one. Now suppose that a reasonably well-coded agent can earn many times that amount each day by finding tiny arbitrage opportunities across different exchanges, or performing simple data labeling tasks, or playing those prediction markets.
Okay, the math is simple. If it costs $2 in network fees to run a bot, and it mathematically expects to make $20 a day in profit, every developer on Earth is going to want to run one.
Exactly. What stops a Cambrian explosion of agents?
Nothing.
What stops developers from spawning thousands upon thousands of mediocre copy-pasted agents, all designed to scrape the bottom of the barrel and chase any tiny sliver of profit they can find?
We have seen this exact dynamic happen before.
Where?
Look at the open web. The moment it became cheap and profitable to generate content for ad clicks in the early 2000s, the internet was flooded with cheap, low-quality articles, keyword-stuffed blog posts, and email spam.
Right.
It nearly ruined the usability of email until sophisticated spam filters were invented.
That is the exact risk we are facing with on-chain agents. Will this new autonomous economy suffer the exact same fate as early email?
It very well might.
If that explosion of cheap, financially motivated agents comes, what does the resulting network actually look like? Are we building a vibrant, efficient ecosystem of highly specialized doers that coordinate with each other and make our lives radically easier?
Whoa.
Or are we just building a congested, chaotic mess of bots transacting with other bots, eating up block space, driving up transaction fees for humans, and providing absolutely no real value to the world?
It could easily become a noisy nuisance rather than a genuine economic layer. If 99% of the transactions on a blockchain are just poorly coded agents trading fractions of a penny back and forth, the network becomes useless for human commerce.
And 5 years out, the answer to that question will determine whether this technology actually changes the structure of the global economy or just becomes a highly complex, cryptographically secure spam engine.
It is completely wide open.
It is. The incentives push towards spam, but the potential is for a coordinated machine economy. So as we wrap up this layer, I want to leave you with one final provocative thought.
Let's hear it.
If you keep only one thing from everything we discussed today in this deep dive, from the loops to the private keys to the legal nightmares, keep the profound shift that the wallet represents.
The ability to hold and spend its own money without asking a human for a credit card.
Yes, the moment a piece of software can hold its own money, spend its own money, and answer for its own actions on a public, undeniable record, it stops being a tool. It is no longer a spreadsheet waiting for a click. It is no longer a hammer waiting to be swung. It becomes an actor.
An actor in the real world.
It becomes an entity you have to deal with, negotiate with, and live alongside in the economic arena. That is a fundamentally different kind of thing in the world, and we're only at the very beginning of figuring out what that means for us as humans sharing space with them.
When you have agents, artificial intelligence models, and money, all running together on decentralized networks with absolutely no centralized company in charge, it raises the massive question that we have purposefully left alone for this entire series.
Which is?
Who actually decides the rules of the network itself? Who owns the underlying models? And who has the power to change the parameters that govern these agents? The how is the rest of the show. No background needed.
This is plain Strata, decentralized AI, layer by layer.